Hi everyone, this video is to cover rationalizing imaginary denominators. As I told you, I would provide for homework. So I'm going to work out problems 1 through 11 odd, and the expectation is that you will have 1 through 11 completed by watching the video and independently complete 2 through 12 for tomorrow. So when we rationalize the denominator, we're trying to eliminate something. Remember in class I told you that we need to use the conjugate to do that. So prerequisite things you need to understand first and foremost is that I squared is equal to -1. So remember in class I taught you that your goal is to eliminate I from the denominator. So keep that in mind. Your goal is to eliminate I in the denominator. The reason being, technically, we have an irrational number with the square root of -1 in our denominator, and we always want rational numbers, particularly real numbers, integers, positive integers at that, in the denominator. So we're going to use the conjugate of 8i, which is -8i. And remember, I told you would create a ratio equal to 1 by using the conjugate. So I want to see this up here on your notes tomorrow. Conjugate of the denominator divided by the conjugate of the denominator. Okay? So that would be -8i is the conjugate of 8i. So I need to just create this ratio, which really is equal to 1. -8i divided by -8i equals 1. And then it's just a matter of simplifying. Well, for this denominator, when we multiply this, 8 times -8, we know it's -64. I times I is I squared. We know that I squared is equal to -1, so when we multiply, we actually end up turning this into a positive 64, and therefore we have met our goal of eliminating I in the denominator. To finish the problem, we simply multiply the numerators together. They do not have to be like terms in order to multiply. So 2 times -8 gives us -16i. Now, if you can reduce the fraction, you certainly should. You can type in -16 divided by 64 in your calculator. If we type in -16 divided by 64, math, enter, we can convert it and get -1/4. So there's two ways we can write it. We can just think, okay, well that's 1 and that's 4, so I can write it as -I over 4. Or I can write it as -1/4 with I beside it like that. So either one of these would be acceptable answers. Continuing on with 3, we look at the denominator, find the conjugate. The conjugate of -5i is +5i. We put that on the top and the bottom. Remember, this just equals 1. That's why we're allowed to do it. We're not really changing anything except how it looks. This is -25i squared. I squared is -1, so my denominator is going to be 25. When I multiply my numerators together, I get -25. The 25s will cancel out, leaving -I as a final answer. Okay? I really don't care which one of these you use, by the way. All right, for number 5, using a conjugate of +4i, when we multiply this, we'll get a 16 on top, 24i. They're both divisible by a common factor of 8. If we type that in, math, enter, 24 divided by 16, math, enter, we get 3/2, 3 on top, and 2 on the bottom. So 8 goes into 24, 3, and into 16, 2. Next, for number 7, this one's slightly different in that we have 2 terms in our numerator, but the process never changes. The conjugate of -6i is +6i. We multiply this together. We get +36. Up top, when we multiply, we're actually going to distribute the 6i to both terms in our binomial. 6i times 4 is 24i. 6i times negative 9i is going to give us negative 54i squared. So earlier we were done when we multiplied the numerator, but remember, none of your answers when doing any operations with imaginary numbers, whether it be add, subtract, multiply, or divide, they should never have any powers higher than I to the first, which means we need to recognize that this is negative 54 times negative 1 by substitution, which will give us a positive 54. So remember also that when you state an answer, you need to state your real part, which is positive 54, and our imaginary part is also positive, so I'll write it as plus 24i. Our denominator is 36. Now, one last thing is when we look at these terms, we need to look and see if they have a common factor. So 54 and 24 and 36, we know that they're all even, so they're all divisible by 2. We could use 2 to reduce, but we should check to see if there might be anything else. So other than 2, let's try 4. 54 is not divisible by 4. 24 is and 36 are, but all three need to be divisible by the same factor. So if we were to just divide by 2, we get 27. So let's try that out. If we divide this by 2, all of these terms, 54 divided by 2 is 27. 24 divided by 2 is 12. 36 divided by 2 is 18. If we can find another factor, we're not quite done reducing. So they're all multiples of 3. So I can divide these by 3. 27 divided by 3 is 9. Or 12 divided by 3 is 4. And 18 divided by 3 is 6. So if we could divide by 2 and 3, that means they were all divisible by a common factor of 6. Hopefully you caught that, but if you're not sure, I would always start by trying to divide by 2 and 3 if they were odd. So again, 54 divided by 6 was 9. 24 divided by 6, sorry, I can't even see it. 24 divided by 6 is 4, and 36 divided by 6 was 6. So all three of those were divisible by a common factor of 6. So this is our final answer. You could have done 6 right away, but just know if you don't see it right away, then you can always try 2 and then continue to look at it from there. Number 9, we have a monomial again down here at the bottom. It's negative I. The conjugate of negative I is positive I. When I multiply my numerators together, I get negative I squared. So it's the opposite of negative 1, which is positive 1. So my numerator is 1. When I distribute up top, I put parentheses if it helps you to remember to distribute, by the way. I times negative 1 is negative I. And I times 8i is positive 8i squared. I squared is negative 1, so this becomes negative 8. And then we need to keep our real part, then our imaginary part. And division by 1 is just 1, so we can ignore the 1 because negative I plus 8i squared divided by 1 is just the numerator, negative I plus 8i squared. So that's our final answer, remembering to write your real part, then your imaginary part. All right, and I'm going to do 11 here, and that will conclude the video. Remember to complete 2 through 12 even. We talked about the conjugate of a binomial as well. Remember, the conjugate of a binomial, all we do is change the operation. So it should be negative 2 plus 6i in both the numerator and in the denominator. So again, that still equals 1. Any number divided by itself equals 1. Well, what's different here is when we multiply our numerators together, or excuse me, our denominators, negative 2 times negative 2 is positive 4. Negative 2 times 6i is negative 12i. Negative 6 times negative 2 is positive 12i. And negative 6i times positive 6i is negative 36i squared. Well, what should always happen is these two terms in the middle should cancel out. That's kind of the purpose of a conjugate. We talked about that in class. Remember to substitute here a -1 for I squared, so it actually turns into positive 36. Combine these integers here, 4 and 36 make 40. And then up top we have a monomial times a binomial. So one term times 2 we need to distribute. So that's going to give us -10i, then 5i times 6i is positive 30i squared. Now, remember that I squared is -1, so this is actually going to turn into a -30. Remember to write the real part first, then the imaginary, all over 40. Then if you have a common factor among the numbers here, you can reduce. So they are all multiples of 10. So if I use 10 to reduce, 10 goes into 30 3 times, 10 goes into 10 1 time, and 10 goes into 40 4 times. So don't forget any of your signs. You should have -30 minus an understood 1i all over 4 as your final answer. I hope that helps. If there's any part that doesn't make sense, please rewatch the video and I'll answer any questions you have tomorrow. But make sure you do 2 through 12 even for homework.